though. All right, so an arithmetic sequence is in series. An arithmetic sequence is a sequence where the difference between consecutive terms is a constant labeled D, the common difference. It's called the common difference. If the same value doesn't appear between each term, it's not arithmetic. Okay? So to get from 1 to 3, you add 2. To get 3 to 5, you add 2. You're adding the same amount every single time, so it's considered arithmetic. When that is not the case, it's not arithmetic. Okay? All right, so this sequence, is it arithmetic? Negative 2, 4, 10, 16. Yes, what are you adding every time? 6, so that's the common difference. What about this one? All right, so this one is not. That was not arithmetic.
Oh, I didn't even know that was an option. I thought these were all going to be.
Well, the question says, is the given sequence arithmetic?
No. Well, yeah.
Okay. So C says an arithmetic sequence has a first term of 20 and a common difference of negative 4. What is the fifth term of the sequence? So the first term is 20, right? What would be the next term? After that, after that, and after that. That's the fifth one. Okay. Any questions about that? So everybody understand the idea of an arithmetic sequence? You're just adding or subtracting the same number to get to the next one. So I don't really care about all this stuff. All right, so there's your formula for an arithmetic sequence. A sub n equals a sub 1 plus n minus 1 times d. What does a sub 1 represent? What does n represent? Term number, right? And what does d represent? The common difference. And a sub n is the one you're trying to find. Okay. There is another formula that I use. Nobody really does this one, but I use it because sometimes you're not given the first term, but the formula works with any two terms in the sequence. So I use P because that represents any term in the sequence. So let's say you want to use the fifth term to find the 12th term and you know the common difference. You can use P as 5. No, you always use a larger number for n. Like this n right here is always the larger one, and P is the smaller one. So if I have the fifth and the 12th term, n would be 12 and P would be 5.
And then AP is that like 12 minus 1?
Yeah.
Okay. So
Yeah. We'll see it in a second. You'll see what I'm talking about later on. Okay. Formula will always be linear. Notice that there's no exponents. You guys know linear equations are arithmetic sequences.
Sure.
Why?
Because they follow the same slope.
The slope. They change by the same value every single time. Okay.
Like how we said sure and then do the answer.
Make sure your final nth term formula is simplified completely. Simplified completely. Meaning you want it in the form of a linear equation. And we know linear equations are in the form of what? Y equals? Right, mx plus b. So we want these to be in the form y equals mx plus b. Okay. Simplified completely. All right. So find what is indicated for each arithmetic sequence. A sub 1 is -6. The common difference is 7. Find the 16th term. So n is 16. I'm trying to find a sub 16. All right. So I'm going to use my formula. So a sub 16 equals -6, 16 minus 1 times 7. Yeah.
Okay, so what if you just like went blank and you like forgot formula and you couldn't figure it out? Couldn't you just do -6 plus 7 16 times?
You could, but that's a long time.
But like I could. Yeah. Like the catch me. Like I don't think I want to sit there. Yeah. Remember that.
All right. So what does this equal? What? 99.
Oh, okay.
So if you have to calculate it in that
Yeah.
sec mode or
Let's look at that. So for this, we would actually leave it in the sequence n mode because it's a sub n. So we would do u of 1 plus n minus 1 times our common difference 7. And u of 1 is -6, right? Everybody agree with that? Okay, so if I look at my table, u of 1. Could be. Let's do that. Nope. How about we just change this to -6?
oh my god.
There we go. So 16 gave us 99. I changed it to -6 instead of doing the u of 1.
So you don't have to put your one here, right?
No, no, you wouldn't have to. Yeah. So let's say you wanted to know the 19th term. You would just put in 19. Okay.
Wait, just for the first u or to the 1, did you still put -6?
No, you can leave it blank.
Okay.
All right, for the next one. Find a sub 40 for the given sequence. What is your first term? What's the common difference? -8. So I'm looking for a sub 40. So that's -9 plus 40 minus 1 times -8. You could either do it just by plugging it in the calculator, or you could just change the initial conditions in here. You should get -321. So you can either plug it in by hand, or you can use the calculator to do it. Questions about that one? Okay. Next one, write the nth term formula for the sequence. So a sub 1 is 8. What's your common difference? 9. So a sub n equals 8 plus n minus 1 times 9. Now, for the nth term formula, because you don't actually have a specific n you're looking for, that is the only thing that you don't plug in, that in a sub n. So you want to plug in your first term a sub 1, and you plug in the common difference. And now we're just going to simplify this. So we're going to distribute the 9. And combine the like terms. So a sub n equals 9n minus 1. And that's our equation. And they always simplify down to something like this, y equals mx plus b format.
I miss learning things. I think I just get it better,
Okay. Considering all given sequences are arithmetic, find what is asked. The 20th term of the sequence is 101, and the common difference is 3. What is the first term? So the 20th term is 101. So that means a sub 20 is 101. Common difference is 3. We're trying to find a sub 1, correct? So if that's the case, we can let n equal 20 because that's the term that we're given, and we use that same formula. So 101 equals a sub 1 plus 20 minus 1 times 3. And we just solve for a sub 1. So 19 times 3 is what? Huh? 19 times 3? So subtract 57 from both sides. And a sub 1 equals 44. Questions about that? Yeah, arithmetic sequences are easy. All right, the next one. What is the common difference for the sequence where the first term is 13 and the 28th term is negative 149? Set everything up that you have and put it in the formula. So my first term is 13. 28th term is negative 149. So that's what I have. So what would I do first? Subtract 13. That should give me negative 162 equals 27 times d. And then we just divide by 27. So our common difference is negative 6. Okay. Last question on this page. Which term of this sequence is 97? So a sub 1 is 1. What's my common difference? 4. A sub n is 97. I just don't know what n is. That's what I'm missing. So I have 97 equals 1 plus n minus 1 times 4. So what do? Subtract 1. 96 equals 4 times n minus 1. Divide by 4. I'm not distributing the 4. Divide by 4. 96 divided by 4 is what? Huh? 24. Equals n minus 1. Add 1 to that. And n equals 25. You could have. It's just easier to go ahead and divide it out to me. All right. Find the four arithmetic means for 16 and 91. This just means find the four numbers between. Find the four numbers between 16 and 91. In order to do that, who do you need? You need the common difference. Okay. So I'm going to let 91 be a sub n because that's the last term. First term is 16. What is n? 6. Because if I have 16 and 91 and four numbers in between, there are 6 terms. Okay? So now I just need to find the common difference. So subtract 16. 91 minus 16 gives me 75 equals 5 times g, divide by 5, and the common difference equals 15. So that means I have 16. What's 16 plus 15? Add 15 again. Add 15 again. Add 15 again. And if you add again, you get to 91. So those are your four arithmetic means. Because it said find the four arithmetic means. So that's the four numbers between 16 and 91. So that means there's a total of 6 numbers. Any questions about that one? Or any other questions about that one? All right, the next one says the 32nd term in the sequence is 534 and the 14th term is 228. What is the 10th term? Who do I need to find? I need to find the common difference, right? So this is where I'm going to use the other formula because I don't have the first term, right? But I do have the 32nd term and the 14th term. So the largest term, not the largest in number, but the largest with the term number, like the furthest term, basically. So the 32nd is the one I'm going to start with. So 534 equals 228 plus 32nd minus 14 times the common difference. Because that's n and p, where p being the smallest term number. So subtract 228, and that gives you what? Gives you what? And 32 minus 14 is 18 times d. So divide by 18. And the common difference is what? 17. So I have the 14th term, and I'm looking for the 10th term. Now, I really could just subtract down, since they're close enough to. So if I just take that 14 term, 228 minus 17, I should get 160. You can just subtract it down. Now, if you didn't subtract it down, you would just use the formula again. So I'd take the 14th term, 228, equals a sub 10, plus 14 minus 10 times 17. Same thing, just use the formula over and over again. So that will be minus 4 times 17 is 68, and a sub 10 still is 160. Either way. Any questions about that one? That's literally what I just did with that, because what's 14 minus 10? All right. Arithmetic series is the indicated sum of an arithmetic sequence. So this is the sum of n terms. First term and the last term. Notice that the only thing you need, actually, before I move any further, what's the sum of the first 100 numbers? From 1 to 100, if you add them up, what do you get? Somebody about to type in 1 plus 2 plus 3 plus 4 plus 5, all the way to 100. What time is it? Oh, we got time. Somebody do it. No, not even close. Nope.
Less?
That's more than 1,000. More than that.
I'd never do that. Can I just look this up?
No. Somebody didn't screw up. I think Jordan just did.
Oh.
This is going to be numbers.
If it was 100 of them. Oh. Yeah, there is. I'm gonna show you why we don't do stuff like what you're doing right now. That's it. 5,050. Okay, so what's 100 divided by 2? 50. What's 100 plus 1? What's 101 times 50?
I definitely did it wrong.
Time out, what'd you say?
Because I got 19,000.
All right, so listen what I just said. You had 100 numbers, right? So what's 100 divided by 2? The first number and the last number were 1 and 100. Add those together and then multiply by the 50. And you get what? 5,050. The sum of the first 100 numbers is an arithmetic series. Because to get from 1 to 2, what are you adding? 1. And to get from 2 to 3, you're still adding 1. So the list of numbers is also an arithmetic sequence from 1 to 100. So to add those numbers together, we use the arithmetic series formula. N represents the number of terms we had. There were 100 numbers, right? The first term was 1, and the last term was 100. So 100 over 2 times 100 plus 1 gives you 50/50. And that's how you do that. I know, it's fun. I always do it. Okay. So this is all you need to add up an arithmetic series. The number of terms, the first term or the last term. That's it. Okay. If you're missing one of these, you have to use the arithmetic sequence formula, the one we learned on the first page, to find it. All right. So this is how you add them up, but this is how you find them if you're missing one. Okay. So this one says, what is the sum of the first 17 terms for the series where a sub 1 is 22 and the common difference is -3? Well, I don't necessarily need the common difference to do the sum, but I do need a sub n, right? I have a sub 1, but I don't have a sub n, so I need that 17th term. So a sub 17 equals 22 plus 17 minus 1 times negative 3. And what do you get?
Yeah.
Negative 26.
Oh, but
It's a negative 3. All right, so now I have a sub 17. So my series formula says the number of terms, how many terms do I have? 17 over 2 times the first term, 22, plus the last term, negative 26. And you get negative 34. Questions about that? Okay. The next one. What is the sum of this series? You have the first term, you have the last term. What are you missing? How many of you are? You're missing n. So you have to go back to your original formula, the first one we learned, to find out what n is. What's the common difference? 13. So 776 minus 9. Divide by 13. And then add 1. And you get 60. So now we find S sub 60. That's 16. And that gives me 23,550. These can get kind of large, but the geometric ones get larger. And we'll do those tomorrow because geometric is actually multiplying the same number every time. So, multiplication grows faster than addition and subtraction. All right, any questions about that? How do you want to do this one? In the calculator. All right, so alpha window. Nope. Because now it's going to give you n, so it's going to look exactly like your problem. How do we know this is arithmetic? It's what? It's linear. It's a linear equation.
So we can keep the calculator in this mode.
I wouldn't do that, but I would just put it in that mode when you need it.
So for B, could we just find the thing and then plug that in the calculator?
You still need n.
When you get in, you could do that?
Yeah.
Instead of that formula?
If you want to, you could. Yeah, if the same thing that you guys were doing before, you could write this as sigma notation and use that in the calculator and find the answer. It might be a little more complicated with these kind of numbers because there's no set pattern. The only pattern you have is the common difference. So that might be the issue. All right, the next one. What is the last term in the series if the sum of the first 60 terms is 5,958 and the first term is 8? So use your series formula. Your sum is 5,958. So that's your S sub n. There are 36 terms. So that's your n. A sub 1 is 8, and you're just trying to find A sub n. Right? So plug everything in the formula and then solve. So I'm going to divide by, what's 36 over 2? So I'm going to divide by 18 to cancel that out. That gives me 331. And then subtract 8. So A sub n equals 323. Questions about that? Yeah, arithmetic stuff is easy. And the very last one. What is the second term of a series if the first term is 9 and the nth term is 105 and the sum is 741? What do I need to find? I need to find the second term. What must I find before I find the second term?
Yeah.
I need the nth term. No, I need n. I have the nth term. I need n. Yeah. So 741 equals n over 2, 9 plus 105. So I'm going to divide by 114 because that's 9 plus 105. So n over 2 equals 6.5. Then I multiply by 2, and n equals 13. So who am I trying to find? Still trying to find the second term, right? So in order to find the second term, who else do I need? I need the common difference. So 105, going back to the first formula, my sequence formula, equals 105 equals the first term 9 plus 13 minus 1 times d. Subtract 9. And divide by 12. D equals 8. So my second term equals 17.